Hey guys, it's your favorite math teacher, Mr. Ng, going over the integrated Math 3 quiz number 8, January 20th, 2021, Module 2, Section 2, Topic 1. Basically factoring higher degree polynomials. Okay, question number 1. Which is a factor of 3x cubed plus 5x squared minus 27x minus 45? Select all that apply. So first thing I'm going to do is see if there's any greatest common factor, and there is, but I also, I don't see a greatest common factor between all of these, 3, 5, 27, and 45. But I can count the number of terms, right? 1, 2, 3, 4. So this one you're going to have to do factoring by grouping. Factor by grouping. Remember, there's two choices here. You can use the box method. Let's do that part right now. So remember here, I'm going to try to go in a Z. So I have 3x cubed positive 5x squared minus 27x and minus 45. All right, in this method, I'm trying to find the GCF of this column here, going up and down, and I think it's 3x. And then the row going in this direction, the GCF is x squared. And then this one is going to be a minus 9. And this one will be a positive 5. I'm going to check my answer by multiplying. 3x times x squared gives me 3x cubed. X squared times 5 gives me 5x squared. 3x times negative 9 gives me negative 27x. And negative 9 times positive 5 gives me negative 45. Okay, so let's hide here in green. These are my answers, but let's write this out. 3x plus 5 and x squared minus 9. Now, if you notice, x squared minus 9 is not any of the choices for number 1 because you have to add a placeholder. And when you do that, here in green, you're going to have to factor again. So this would be, a times c would be negative 9. My b value would be 0. My two numbers are 3 and negative 3. Okay, so this would leave us with 3x plus 5 and x plus 3, x minus 3 is our answer. So here is my answer. So let's see, this problem says check all that apply. So it could be multiple ones. So 3x plus 5, this would be this one. And x plus 3 would be this one. And x minus 3 would be this one. I don't know how the computer grades it. It's at 1 point, so I don't know what happens if you get 2 correct and minus 1. It just gives you a score. So I'll let the computer do that pretty consistently. Question number 2 says factor 9x. Oh, let's go back to the different types of methods. So that was the box method. Let's go ahead and use a second method. I call this one 2 GCFs. Let's write the problem again. Okay, in this problem, let's see if I can just use my colors. This one over here, there is in yellow a GCF, and in green there is a GCF. So here in yellow, I think my greatest common factor is going to just be an x squared. So x squared times this, which would be 3x. And x squared times something would give us 5x squared. So this one would be a plus 5. And then in green, I'm going to have a -9. -9 times 3x. -9 times. So these numbers I'm getting, I have to think of. This would be a +5. Okay. How do you know you did this correctly? These numbers in the parentheses are exactly the same. So that's the first GCF is x squared and -9. My second GCF is 3x plus 5. Put it in parentheses. And then we're going to go over here and find those that we did not highlight in red. So that would be x squared minus 9. And we just did this problem to the left, and it's going to be x plus 3x minus 3. And this one is 3x plus 5. All right, so I just wanted to show you guys there's two different methods there, the box or 2 GCFs to do that problem. Okay, all right, let's try number 2. This problem is the chunking, no chunking. How do I know that? Remember chunking, so let's show you first by chunking. This works when you focus on just these two right here as your greatest common factor. Do they have a greatest common factor? They do. They have a 3x. So 3x squared. Okay, because 3x times 3x is 9x squared. Now I have to think of something where 3x times something equals -30x. That would be a 10. And this would be a 25. So my substitution, let's go ahead and highlight this in blue. My substitution, let's use, I don't know, let's use a triangle. Triangle equals, well, it looks like a box already, doesn't it? Let's just do that. Box equals 3x. So now I have the box squared minus 10 times the box plus 25. And the reason why I did that is so I'm going from a value of 9 as my a value. Now my a value is just 1. So I have 1, -10, and 25. So a times c would be 25. My b value is -10. My two numbers are going to be multiply to be 25 and add to be -10. So that's -5 and -5. And then let's just put our box back in there. Okay. In years past, students would make this mistake right here. So put your box back in. Right there. What is our box equal to? It is equal to 3x. So let's go ahead and write that. 3x minus 5. 3x minus 5. And you'll notice that these are the same. So you can say that you have a quantity or 2, or the exponent is 2. So this would be choice B is your answer. All right, let's show you that same problem with no chunking. No chunk. So 9x squared minus 30x plus 25. This is not going to be fun. Okay. Let's do it over here. I have my x in my box, and let me pull up my calculator. That's how fun this problem will be. And I'm going to do 9 times 25, which I think is going to be 225. Okay, 225. So just to recap, this is your A, B, and C. A times C is 225. My B value is -30. My factors of 225 are 225 times 1. I know that it is also 25 times 9 because we just did that. My trick was putting into the calculator. I Actually, I can do it on here. I'll show you guys with my free calculator, graphing calc. Go to y equals, and then do 225 divided by x. And then I'm going to do a table set, second table. I want it to count by ones. And switch to auto. So then I'm going to go press table. And what it's doing is on the left side, it's doing 225 times 1. Your answer is 225. And so I'm looking for all the ones that are divisible with no decimal. So 225 divided by 3 is 75. So that's one of them. 5 and 45. 5 times 45 will give me 225. 9 times 25, we knew that one. And then 15 times 15. Okay? So let's write down all of those. 375, 545. We said 45 and 9180. 5 extra 2, yeah, 225. And then 15 times 15. Okay, which one of those? It's going to be this one, 15 and 15. Negative 15 times negative 15 equals a positive 225, and negative 15 plus negative 15 gives me negative 30. Okay, I have to put that into the box. And so the yellow right there is splitting the b term. That's why you're adding an x here. Let's go ahead and write. This one's going to go in the top left. This one goes in the bottom right. And we're just going to factor that one. GCF in that direction will be a 3x. GCF in this direction will be a 5. And it looks to be a negative 5. Because if you go over here, GCF this way would be 3x and then a negative 5. And so 3x, you can see there is the same answer as the one to the left. You have 2 of those, so you can do exponent times 2. Okay? All right, so those are both methods. Question number 3. Which of the following expressions are examples of either the sum and difference of cubes? Mark all that are an example of the sum of cubes or the difference of cubes. Okay, so it's kind of like multiple choice. A couple things that you need to remember. You could just write out the formula. I'll write them out really quickly for you. The sum of cubes is just a plus b cubed. And this is where I'm going to write it out, is my SOAP. Okay, so, and then I'm going to highlight this symbol so you can see it. S stands for same, opposite of positive, which is negative, and AP, which is always positive. Okay, and that SOAP actually applies to the other one as well, so let's just fill that out. So AB, A squared, AB, B squared. Let's do that for this one over here. Now we're going to have a minus sign, so A minus B cubed equals, what's the same? A, same is minus, opposite of minus is a plus, and then plus. Okay, so it's just a formula you have to memorize. But SOAP's actually going to be in here. Watch this. It doesn't tell us how to start, but I can just eliminate problems based off of SOAP. Okay, let's write out SOAP. Same, opposite, always positive. Okay? Look at this one. If this starts as a positive, then this one has to be a minus, but it's not, so we're not picking that one. Okay? Okay, so I have same, so positive, opposite, always positive. That one works. Okay, let's look at the next one. Same, opposite. Are these opposites? No, so wrong. It's like a D. I have a plus. So what's the opposite of that? That's a minus, then plus. So if your b value is 4, 4 squared is 16, so that works. It's like the same thing over here. I have a minus sign, so again, SOAP, same. Opposite, this is opposite, that's good. And always positive, good. If my b value is 10, so this is going to be 10 squared, which is 100, that works. And the last one, same, opposite, always positive. That one works too. Okay, so we have 3 of them as our answer. B, D, E, and F. Okay, 4 of those are sum and differences of cubes. All right, question number 4. If you're looking at your flow chart, you're always looking for first the GCF, okay? So, whoops, does this problem have a GCF? Well, you can break them into factors. That box is probably not big enough. What are the factors of 405 x to the 4th? Well, I'm going to look ahead and not cheat, but think ahead. 5, and then how many times is 5 go into 40? That is 8. And how many times does 5 go into 5? Goes in once. And then negative 5x squared is negative 1 times 5 times x squared. I'm going to circle the things they have in common. So that is a 5. And they also have x squared. Okay, what did we not circle? So 81 x squared. And then over here, you just have that negative 1. So 5x squared is my GCF, and then I have this one here. Okay, you'll notice they'll try to trick you with this one. I don't think that is the correct one, but I did leave a big space because I know it's going to be a difference of squares. Okay, I'll show you the shortcut after I do it the long way. I put a 0x in there because half of 2 is 1. So what we're going to do here is we're just going to factor what's inside the... We're going to factor what... That's not an x. We're going to factor what's inside there in yellow. Okay, let's do that together. You could also use the chunking method here, but A, B, C. A times C is negative 81. My B value is 0. My two numbers are going to be 9 and negative 9. 9 and negative 9. We are splitting this one so that has an x there. In the top left will always go the whole A term. And the C term always goes in the bottom right. All right, so GCF going this direction is a 9x. GCF in this direction is a minus 1. Guys like purple. This direction, I think it is going to be a positive 1, and this direction will be a positive 9x. So from, let's choose green here. (9x minus 1), 9x plus 1 is going to be our answer. Okay, so which is the factor? That means it's only going to be one of these. And I see that in B. So B is our answer because it's that one right there. Okay? How do you do this problem with this portion right there with the shortcut? If it's called the difference of squares, because if you can take the square of each side, Square root of 81 is 9. And the square root of x squared is x. So how that works is you'll put 9x, 9x, and the square root of 1 is 1. And then you'll just make 1 plus, 1 minus. And so this is the same thing as what we did in the both x in the box. So a different method. It's hard to figure that one out when you kind of see if you can take the subtraction sign and then they're both squares. Okay, number 5, factor this one. It's a trinomial, 1, 2, 3. And what is half of 4? It is 2. So I can just use my Xbox method of factoring. But remember now, if you just use a equals 1 is just for the x, and you need both the x and the box if a is greater than 1. Okay, so in this problem, a is 1, it's right there, b is 2, and c is negative 24. So I don't need the box, I could just, but it'll help you understand why I got the answer, okay? So a times c is negative 24, b value is 2. What are the two numbers that multiply to be negative 24, but they add to be 2? I'm thinking of 6 and 4, and this one will be a negative. Okay, remember those numbers in red. I'm going to use this in the box. We don't have to, but the box, the red, is splitting this term, so I have to add a x squared. 6x squared minus a 4x squared gives you a 2x squared. Okay? And then top left, we're going to put always the a term, and the c term always goes in the bottom right. We're just going to take out the greatest common factor. That's going to be an x squared. Greatest common factor. I'm thinking 6 here, and I'm happy with that for now. Let's pick a different color I haven't used. How about orange? This direction is going to be an x squared. Greatest common factor, I think it'll be a negative 4. All right, let's double check our answer here. X squared times x squared equals x to the 4th. X squared times negative 4 is negative 4x squared. X squared times 6 gives us 6x squared, and 6 times negative 4 gives me negative 24. Okay, why did I say in red you didn't need that? Well, look here. X squared plus 6. Hold on, sorry, I missed that. Plus 6, do you see that? You can just put it there. And the other one is going to be x squared minus 4, which is up here. All right, a little tricky in this problem. You have to do it again. You have to start recognizing the difference of squares. If you don't, put a placeholder 0x, and then when you factor that, that one's just going to be x plus 2, x minus 2. All right, so this is the answer. And let's use some magic. Ta-da! There's my answer. Just need to erase that little part. And that's my answer. Remember, the order in which you write those binomials or parentheses do not matter. They can be switched position as long as you have all of those. Okay, last one. Factor completely. And this is a trinomial. There's 1, 2, 3. Okay, pay attention here. What's half of 5? Is it 3? The answer is no. Which means you can't use Xbox yet. No Xbox. Okay. What does that mean? You should always use GCF first. So again, you can do a strategy. I'm just going to place it in a big box with 3 bins because I have 3 times x times x times x times x times x, and 2 times 5 times x times x times x, and 7 is 7 times x. Do they have anything in common? They have 1x. So my GCF is x. And then what's left is this, 3x to the 4th plus 10x squared plus 7. Let's write that. So now I have this. All right, let me highlight this with yellow. That is a trinomial. Half of 4 is 2 with the exponents there. Now I can use my x box method of factoring. In this problem, I have to use both. So again, we're looking there in the highlighted yellow, A, B, C. So A times C is 21. My B value is 10. My two numbers that multiplied to be 21 are 7 and 3. And 7 plus 3 is 10. So I have 7 and 3. This is splitting this term right here, so I have to add an x squared. The first term always goes here, and the last term always goes right here. Let's go ahead and find out our GCF here. GCF going in this direction is x squared. Okay, this one doesn't look like anything, but I'm going to put plus 1. Plus 1. And this direction, 3x squared. That's a 2. And this direction, plus 7. Let's double check our answers, seeing if we can just multiply it. X squared times 3x squared gives me 3x to the 4th. 1 times 3x squared gives me 3x squared. X squared times 7 gives you 7x squared. And 7 times 1 gives you 7. So, okay, pay attention. I just highlighted those in red. So let's write those out. X squared plus 1 and 3x squared plus 7. And don't forget you have that x in front. So this is my answer. And just copy it, paste it. Boom, kind of messy. Let's not do that. Let's just write it out. It doesn't fit in the box. Okay, if you're looking at these binomials I'm writing, you'll recognize that they are prime, which means if you put them into the x box method, you can't factor them again. Okay, so that's the answer for number 6, and that's the end of our quiz. Hopefully those were helpful for you guys. See ya. Bye.